All right, we're going to start the last lesson of Unit 1, Section 1.4, Transformations of Functions. You should have a handout with graphical transformations with some rules and steps, another handout with all the different parent functions that we are going to familiarize ourselves with this year, and last but not least, a note-taking guide, which I will increase in size right now. So let's start with this note-taking guide, and then we'll look at the reference material. So transformations of functions. Throughout the course, we have become familiar with several transformations of a graph of a function. And what I mean by that is in prior units, such as those covered in Algebra 2. So this is the general format of any kind of function. And when I talk about f of x, actually, let me go back over here. These are the f of x that I'm talking about, okay? Any one of these functions right here. Notice that in each one of these, under each one of these graphs, there is an equation. The f of x equals a, f of x equals x. Each one of these equations represent the picture of the graph above it, okay? So these functions right here are parent functions, and they are going to shift left, right, up, down, compress, reflect, okay? So that causes these equations that I'm highlighting in pink, they're going to change up, right? If you start moving these, they're going to start changing up. So when I say there is some number a in front of the function, that's a coefficient. The minus h is going to have an effect on the function, as well as the plus k will also have some sort of effect. So let's see what is exactly happening with some discovery through looking at examples, okay? So let's explore the effect of h. So particularly right now, we're looking at this piece right here, okay? What effect does h have on the quadratic function? So recall again, the parent function of a quadratic function, where is it, is right here, okay? It is this U-shaped graph that goes through the origin, and we are going to see what happens when that particular graph shifts. So they're going to give us some examples here. So notice the graph is no longer centered. What did it do? It seems to have moved to the right 1 unit, okay? So I'm going to put R1 just to make it easier. Over here, it seems that this went left 3. Notice this one went right 2. And this one went left 1. All right. So with that being said, right, look at the equation, and I want you to see what your observation is. Right 1, left 3, right 2, and left 1. Do you see what's happening? So what does the effect of h have on the function? Well, first of all, the number that's represented by h, which is this number right here, is going to be the horizontal shift. It's going to be the horizontal shift. So it's going to help. That number tells you how far you're going to move left and right. But what you need to make sure you do always is do the opposite of the number that's being displayed inside of the parentheses. Okay, so you're going to do the opposite of what you see inside the parentheses. Okay, so that makes sense here as to why we were seeing this right 1 when it was a -1. We saw a left 3, even though it was a +3 up there. -2 told us to go down to the right 2, and +1 told us to go left 1. So for horizontal shift, I want you to always do the opposite of what's inside the parentheses. Now, let's go look at the K value. And the K value, let's see here, let's highlight it here in yellow. And so in this particular problem, you're seeing that they want us to look at the odd power function. So let's go back to this parent function. The odd power function is this one right here. So we have this odd power function going through the origin, and that yellow graph is going to shift based on the numbers. Let's see how the numbers affect this parent function. Okay, so our odd function was originally like right here through the origin, right? And so it definitely has done something different. And so I'm going to, again, let's do some drawing here. This graph seems to have gone up 1. So I'm going to put up 1. Now this graph seems to have gone down 3 units. This one went down 2 units. And this one seems to have gone up 3 units. Forgot to put my U. Up 3 units. So if you again compare the K value with what's being said, notice in this case with the K value, it's going to attribute itself to vertical movement. You are doing exactly what it says. So what effect does K have on the function? It is going to give us the vertical shift, or the translation of the graph. And in this particular situation, do as the value says. Okay. I'm saying this very much in layman's terms, of course. So do exactly what the value says. Okay. Now what I do want you to notice is that this value is outside of the function. Okay. Outside, of the function. It is attached outside of the function. It doesn't affect the x, it's going to affect y values. And last but not least, we have the effect of these coefficients of the function. So let me shift back over here. Actually, we're talking about, what are we going to use? Let us first erase this color here, and we will use the color, let's see, this off green. So anytime you have a coefficient A, that has to do with the vertical stretch or compression that's happening. All right. So notice that this coefficient is a number other than 1, is another number other than 1. And you only look at this the number. Do not take the sign, because the sign in front of that 3, it has to do with reflection. And so this value A is there. So if you notice, if the number is bigger than 1, you can tell that the graph stretched. So we're going to put a little stretch here. This one stretched vertically. If it's less than 1, it's going to compress vertically. All right. And even though this negative, you're going to think it's a -3, you're actually taking the absolute value of -3 because you're ignoring that negative. The 3 is going to imply that this one also stretched vertically because of it being larger than 1, but notice it flipped because of the negative. And you can make a note for yourself here. This is going to be a reflection over the x-axis. And that's in your chart that we're going to talk about soon. And this one again is less than 1, so it also compressed. All right. So greater than 1, I guess we can put here greater than 1, your A. It's greater than 1, your A is less than 1, greater than 1, and less than 1. Okay? Okay. So what does this effect have? It is going to provides us with the vertical stretch or the vertical compression factor. And it's always a multiplier, by the way. All right. It's always going to be a multiplier. And it affects your Y values, okay? Y values. All right. So let's look at this reference sheet so that we can dive in and go practice some problems. So the reference sheet here is going to help you as you glance over at it, practicing the graphing. Please remember that with graphing transform graphs, you must follow the order. Okay, order does matter. So let's write this down. Order matters. So you have to go through this list asking yourself which, looking at the function, does there have horizontal evidence? Does it have shrink or stretch? Does it have a reflection? You need to stick to that order. And you can use these transformation rules to help you remember. Okay? So if the number is outside of the function, you know that it is going to be vertically moving. If you have values that are adding or subtracting to the x, it's going to move horizontally. Negatives cause reflection. So notice the position of those negatives. One's outside the function, one's inside the function. And then we already talked about vertical stretch and compression. We will not do this. Okay. So let's go to delta. So here we are with your homework assignment, 1-4 homework function transformations. The first unit or the first section is very straightforward, trying to make sure that you guys can understand the very, very basic. All right, so here they're giving you the graph of y equals f of x, and it's represented by this dark, solid black graph. And this black graph underwent a transformation and became this orange graph. So what you're supposed to do is describe the transformation that happened so that you can figure out which one of these is the final answer as far as the representative equation to this. So let's describe this. Is there a horizontal translation? And yes, we notice that the graph moved right 4 units. Then we ask ourselves, did it stretch or shrink? It doesn't look like it did. It looks like it maintained its shape. Reflection. Yes, it did. It reflected over the x-axis. And how about vertical translation? It stayed pretty put on the x-axis. So we look here at which one of these 4 would represent right 4 and reflect over the x-axis. Well, right 4 means, over here with the right, that the number being affected is going to be inside the parentheses because it has to affect the x. And with horizontal translation, we always do the opposite. So if I need to go right 4, I need to look for negative 4 to the x. So here's x being negative 4, and so that might be an option. And it doesn't look like it's happening with anything else because this here would be left 4. So we are just left with this option because these are the only two x's that had numbers adding and subtracting to them. Here, nothing's happening to those x's. So we will put this one in. Oh, and by the way, sorry, we said it reflected over the x-axis, and that's what that negative is for. Let's try another one. So right here, horizontal translation, it has a right 4. So right 4 means what? Which one of these? We have to do the opposite. So it's going to be one of these two. And then the graph went up 2, so it has to be this one. And so use this notation here to help you if you need it. All right, and the more you practice, your goal is to not look at this table. So that's how you will do the first section. Let's go to the second section. Second section just starts having you do the graphing yourself. So we start first with horizontal translation. We do notice that there is a +3 adding to an x, and that is implying horizontal movement, opposite. And so you use the green button to drag your graph. And that's the only thing that happens because this is a quadratic equation. All they did was add the 3, and that's it. So that was really straightforward. Let's see if there was one that's less than that straightforward. Okay, this is a good one that people get confused on. So this equation comes from the exponential equation. Let me show it to you over here on the parent functions. So exponential is this one right here. So do you see this one right here? All right. So this value right here, the value is called the base. This base value, what's being raised to the exponent, that has nothing to do with your transformations. You get to ignore the a value, that base. So the base that I'm talking about that I need you to ignore in this problem is this 2, okay? This 2, I don't know if I can highlight it. Let me use my arrow. That 2 is meant to be ignored, okay? So the only thing you care about is about this negative, that negative, and that +4. That's all you care about. So let's go through the chart. The first thing we ask ourselves, does it have a horizontal translation? Nothing's adding or subtracting to the x. Stretch or shrink, there's nothing in front of that 2. To give you an example what it would look like if it did, let's throw in a coefficient of 3. It would be like this, -3 times 2 to the negative x plus 4. Okay, this is how the stretch and compression would be affected if it had this type of number in front of it. This right here, this number, the 2, you ignore it. That's just part of your parent function, okay? You would ignore it. All right, so there's no stretch or compression. There is reflection, and it doesn't matter which reflection you do, but we're going to have both because it has a negative in front of the function, which is that one right there, and then the negative inside the function with the x, which is that one right there. So I'm going to take one of these blue dots. I'm going to jump over the x-axis. So this is 2 units up. But if I jump over the x-axis, it has to be 2 units down from the x-axis. And then I have to jump across the y. So I'm going to take this, which is 1 space over, and move it right here on the other side. And then the +4 is that number that hangs out at the end. You do exactly what it says. So mine is a +4, like the +D, you go up 4. So take the green dot, 1, 2, 3, 4, and the green dot moves the entire graph. Let's get a little bit harder, and we'll do one more of these and one more of the other section. So here is there horizontal transformation? Well, we can, hold on, trying to make sure you guys can see. The horizontal transformation, there's an x that has a number adding and subtracting to it. So that -4 implies what? And if you said right 4, you are correct. Stretch shrink, nothing. There's no coefficient. Reflecting, there are no negatives. Vertical translation, yes, there is. A number dangling on the outside, down 1. Let's hope that the next one's a little bit harder. I'm trying to get one. Let me do this really fast. I'm looking for one that, let's see if the next one works. Well, I'm going to pause the video and find one. Well, let me talk to you about this problem particularly. Notice how this has a coefficient of 1/2. So that's going to be a vertical compression because it's less than 1, right? So what you're going to do is you have to multiply by 1/2 because that's your vertical compression. So you are going to take one of these dots and find their y value, and you have to multiply it by 1/2. Well, if you multiply by 1/2, you're in essence taking the division of 2. And which one of these y values of these blue dots is easiest divided by 2? What I would choose either the 4 or the 2. So let's say if I choose the 4. So 4 divided by 2, because it's multiplying by 1/2, would become 2. And notice how it was compressed because it's less than 1. And so this is your final answer. Let's see. There we go. This is more like it. This is what I was looking for. So here's another example. We do, first, we do the stretch shrink coefficient. In this case, it's going to compress. It's going to shrink. So 1/8 means divide by 8. So which one of these blue dots has a y value that is easily divided by 8? Well, it's either going to be this one, 8, or -8. So because I'm going to choose this one, 1/8 means you multiply 8 by 1/8 because that y value is easy to multiply, and it's going to become a 1. So this blue dot is no longer at the height of 8. It is at the height of 1. So it got compressed. And then the -3 is that it dropped down 3 units. Okay, so that's how you do those. Last but not least, here is our transformation of a point. So let me get some space over here. You're going to notice in your chart that I also provide some rules for changing the coordinates. All right, let's erase this. So we are given a point of -5, 6. So I'm going to put -5 and a 6. Okay. Now, because I know people are visual, I'm going to go ahead and draw a graph paper here a second. Okay, there's your little graph paper. So -5, 6 is this dot, to the left 5, up 6, and it's going to go through some transformations, okay? This is the description. G of x equals -f of x minus 2 is telling us what's happening. So the first thing you do is ask, is there any horizontal transformation? And then you look at your equation and you're like, yep, that means that it went to the right 2. And then you ask yourself, is there any stretch or shrink? There isn't anything because there's no number other than 1 right there. Is there any reflection? There sure is a reflection right there. What does that reflection mean? That says you reflect over the x-axis. And that's the only thing left to do in this problem. So if you go right to, think about this, -5 and 6 is the starting point. If you go right to means it affects the x, because it's horizontal movement. So -3, 6 becomes your new point. Let's see if that's true. If I go to the right 2, 1, 2, I do end up at -3, 6. Let's put it as a black dot. Okay. And then we're supposed to reflect over the x-axis. So reflect over the x-axis means jump over, right? And so because we're jumping over from -5, 6 to the other side, -3, 6, the other side is going to be -3, -6. So that's the reflection. And so that would be my final answer. So we'll come over here and you'll type -3, -6. -3, -6, and close the parentheses and submit. Okay, that's all you do. That is all. Hope that helps.